So BGP is a path vector protocol. So like we have link state routing protocol, we have distance vector routing protocols, we have path vector protocol as well. So BGP referred to as a path vector routing protocol because it uses the AS path as a vector. So how it uses the AS path as a vector to prevent basically routing loops. We'll discuss about this. Basically, what is a path vector protocol? So basically, first thing is it will guarantee a loop free path, as well as path vector will not rely on cost like a link state routing protocol that relies on that, right? So if it is not relies on cost, then it will relies on the path, right? So how it will relies on the path? Basically, whenever R1 advertise 1.1.1.1, so basically it will advertise the path as well. For example, this is a green router, so it will advertise, say that it is a green one, right? Something about the path. So R2 will also advertise. So when R2 advertise, so basically it will also advertise with 1.1.1 with, for example, a red, and it is coming from where? It is coming from green. So it will include that. Similarly, R3 will also advertise, and R2, R4, right? Now R4 is also connected with R2 and R1. So whenever R4 will advertise 1.1.1.1, says that like it learns from yellow, it learns from red, it learns from green, as well as it will update its own, as it learns from blue as well, regarding its own path, regarding its own availability of, regarding its own device information. So based on that, it advertise. So whenever R1 receives that, it found that, okay, it's already been learned from me, right? Similarly, whenever R2 receives this, it able to see that it's already been learned from me, right? So based on this, router 1 and router 2 will reject the advertisement, right? So basically, it's already indicate that it's already, whenever I'm getting something, it is already there in the path, it's already been there. R1 and R2 is already been present in that advertisement. So it will not able to accept, it will reject that. This brings, basically, provide a loop free path. This guarantees a loop free path basically. So basically, when we talk about BGP, so BGP is, it treats its own autonomous system, first of all, as a single point of any given destination, right? For example, when we discuss about why BGP, right? In that we discuss something about as per BGP, an autonomous system is a single entity or a single thing or a single box, right? So whenever it advertise any path, any prefix, for example, we have, so based on this topology, so from a BGP perspective, right? So BGP says that each autonomous system is a single entity for a given destination, or an autonomous system is a single thing or single box from a outside world perspective, right? Whenever, for example, this is a prefix, whenever it advertises to, for example, the neighboring AS. So this 1.1.1.0/24 prefix will be advertised, and it will send its own autonomous system along in that basically prefix. So 1.1.1 is, for example, 1.1.1 is being advertised, 1.1.0/24 is being advertised, adding its own autonomous system and advertised to 65002 autonomous system, right? So then 65002 also advertise 1.1.1.0/24, and it will put his own autonomous system, update his own autonomous system, followed by from where it is coming, and then advertise to 65003, right? Similarly, when R2 advertise to, for example, 65002, so R3 will also advertise to 65003. So 1.1.1.0/24 is advertised by 65001 as the AS number. Update the AS number and then advertise it. So now 65003 receives two prefixes from different autonomous system, right? So whenever it receives up any prefix, so basically it receives from here and then it says that, okay, this prefix already I received. Then it will see, okay, there are two autonomous system number, I have only one. Then based on the best path selection, it will calculate and it will place the route in the routing table, the best route, right? But for example, let's say this is not the case, right? R3 is not advertising. So 65003 got the route and then it will now it will advertise, right? So now R9 will advertise 1.1.1.0/24 along with 65003. It will update its own autonomous system, 65002, this one, and then 65001. So this route will receive by R3. Once this route received by R3, what will happen now? So R3 will receive it. Okay, R3 will receive it in basically ribbon table. We'll discuss that. What is ribbon table? So inbound route, it will receive in the inbound and then it will check whether my autonomous system is there in the network or not, in that route or not. If it is there in the route, so it will find that, okay, there is. So I am the originator. So basically it will drop this one. So it will drop and this is how it will prevent loop. Same route is getting advertised by the same autonomous system and then we are getting back. So based on this, it found that, okay, I'm getting this, but because of this path vector, because of this vector that already been there in the route, so it is able to figure out. As a result, it will give a loop-free path. So based on this, BGP is a path vector protocol and the vector is basically autonomous system. Whenever there is a route update happens, it will put the information about the autonomous system information, this vector. So basically, whenever it goes from 65001 to 65002, it advertises. 65002 advertise to anyone, it will put its own. So every time, whenever it goes from one autonomous system to another, it will keep on adding those autonomous system. Because an autonomous system from a BGP perspective is a single point or a single box or a single thing, you can say that, from a BGP perspective with respect to an outside world, right? If you are sitting over here, whenever a route receives, you say that, okay, 65002 is advertising a route. If you are receiving a route from 65001, 65001 is advertising the route. You are not saying that I am getting from R3, I am getting from R2. You are saying that I am getting this route from 65001 or I am getting the route from 65002. So basically this is coming from only one entity whenever we are advertising. So it is hiding basically it hides the topology information. Whenever we are advertising, it only says that 1.1.1.0/24 is being learned from 65001. How A advertised to R1, R1 advertised to R3, R3 advertised to R2, nothing. Only it had coming from this autonomous system. That's all. Based on that, it hides the information. So based on this AS 65001 and 65002, there is one customer A and customer B is there, right? So we know that it's one entity 65001 in terms of when you are at 65002. From 65002, when you see, look at here, you see that this is a one entity, right? As per BGP. But in this case, BGP only can avoid loops when we are talking about when it's a eBGP. When we are talking about two different autonomous systems, right? Within the autonomous system, we cannot avoid loop using autonomous system number, right? For instance, R1 advertise to R2, R1 advertise to R3. So R2 will advertise that 1.1.1.0/24 routes along with stating that 65001. Similarly, R3 will also advertise 65001 as an autonomous system with 1.1.1.0/24, both receives. So R4 within the autonomous system will advertise this route. This route also advertise to its iBGP neighbors, right? So will 1.1.1.0/24 are coming from this one, everywhere we will have this one. So based on this autonomous system, it will not able to say that there is a loop, because inside an autonomous system, AS path do not calculate. You cannot prevent loop using AS path. As a result, BGP will ensure that only one route will be installed based on route selection criteria, or based on, for example, based on route selection criteria, how it is learning, how many autonomous system paths are there, local preference and all. Later on, for example, also it consider the IGP shortest path in order to reach to the destination, right? For example, one will be selected at a time, and based on that, so for example, I select, so this path, whenever B wants to communicate, this is the shortest path or this is the best path to reach the destination. So always R4 prefer this link to go into 65001. So whenever we are talking about an autonomous system within an AS, basically BGP relies on the autonomous system to prevent loop for eBGP between the autonomous system, but BGP will not rely on autonomous systems within 65002, right? For that, it need to ensure that every router, whosoever got, for example, this router got 1.1.1.0/24 from R4 through this path. Also, I receive from this path as well, right? Then BGP will ensure that, okay, which is the shortest path, or based on which attribute it is looking best to me, and based on that it will install. And based on that is installed, so the data plane will be accordingly. So one more important concept of BGP is, for example, R1 advertise 1.1.1.0/24 to its neighbor. So R2 receives it. Do we mean that? So R1, whenever R1 advertise, that advertisement is basically in the BGP update message packet. So this update message will receive it to here. Now R2, what R2 will do, R2 will store that, consume that in the memory, and create a new update packet, and then it advertise to the neighbor. Okay, so update message is not end to end. Update message is basically consumed whenever it advertising, and then create a new one. Like in, for example, ISIS, we have within the area, it will, all LSUs are flooding across in the entire level or area. Similarly, update message is first consumed, then new update packet will be generated. And what do you think that when an AS is added to a prefix, so AS path will be added to a prefix in eBGP neighborship when it is advertising towards R4, it advertise and add the AS path, and then it reach to R4. So while advertising, it adds the autonomous system number. So AS path gets added while advertising from R2 to R4 in an eBGP neighbor. Basically, the loops happen. For example, like in our previous example, that I advertised R2 advertised to R4, R5 advertised R8, right? So now when R9 with 1.1.1.0/24 advertise with its own AS path, 65002 AS path and 65001 AS path, when it advertise, when R3 receives it, right? So when R3 receives in ribbon table, then it will check, okay, is the AS path listed anywhere in the AS path and whatever update is coming. It will check in the receiving side of it, inbound side of it. Okay, it's already been there, so it will discard that route. So whenever we talk about BGP, so BGP receives that in a ribbon table. So that is an inbound. Then it update in the rib local table, which is your routing table. And then rib out is basically when you advertise those routes. So as per BGP, whenever, for example, whatever active routes are there in the routing table, eBGP advertise all the active routes by default, right? eBGP advertise all the active routes. So whenever a route receives, it receives in ribbon table. Then based on the checks, everything happens. We'll discuss this one in our next module. But whenever it receives in ribbon table, wherein the ribbon table, after it receives, it will do a check for the AS path, whether my AS path is present. This is where we do a loop prevention for BGP, eBGP. And remember, there is no loop prevention for when we talk about an intra AS. So eBGP can do a loop prevent from AS path, but iBGP cannot using AS path. There is a different mechanism.